Okay.
Oh, cool.
Okay, so as I was saying, in taking these trips to Israel, doing work with teenagers over the years, I'm always looking for snails. So for example, in this picture, what you're looking at is a rock wall across the street from the youth hostel where we stayed. And it's full of snail shells. So I'm always looking. Let me go back in, there we go. And as you can see, I'm taking pictures of snail shells for iNaturalist. This is, I guess, a good time for me to point out that the Nature Authority in Israel has strict rules about collecting live animals. All mollusks are protected, so what you're going to see is a lot of dead stuff. So just FYI. Well, you'll see some pictures of live things too, but I also like taking pictures of insects and posting them to iNaturalist. So these are some just pictures taken with my iPhone of some of the bugs that I run into on this trip as well. So
it's all iPhone pictures?
Just iPhone pictures, right. And this is actually my favorite observation, this tiny little scorpion. He's about an inch in size. As you can imagine, I found him while I was turning a rock looking for snail shells. So what can you do?
Cool.
That's
Okay.
cool. Very cool.
So, quick background. Israel, as I believe you know, is this little country here. It is very small. It's about 250 miles long. Here in the middle, it's 9 miles wide. So it's a very small country. It's interesting in that tiny space, we have 100 species of land snails, 45 genera in 22 families. And that's in about 22,000 square kilometers. And just to give you an example of comparison, Northwestern Europe and Britain have, I'm looking at my notes here, 279 species of land snails in 850,000 square kilometers of area. So what you have is incredible species diversity in a tiny area. And we're going to look a little bit at why. A lot of it is about location, but also climate and a whole range of other factors. One of the other factors, if we go back to the map, as you can imagine, there was no glaciation during the Pleistocene. The glaciers didn't get this far south. So we had ongoing speciation through that period. As you'll see in a moment, there's a wide range of climates. And one of the other aspects of this area that makes for snail diversity is it's all limestone. It's all calcareous material, lots of calcium, lots of resources to make shells. If we think about the needs of snails and look at this area in that context, they need food, obviously, but they need water and they need calcium. Those are the three main resources. So we're going to look at this area in that context. So let's start with water.
So you say that the snail require like the environment with the calcium. What is the reason?
Yes, because they need to harvest calcium to make their shells.
Oh, I see. Because it's not in the salt water, right? So it's in the land, so they need calcium.
Well, in marine snails are pulling calcium out of the water as well.
Yes.
Right, but these are, again, I'm talking land snails don't have the luxury that marine snails have of being in an environment that's rich in minerals and resources. They have to harvest those. So they have to find a source of calcium. In some cases, it's even shells of other snails.
I see.
Let's look at water for a minute. Here's a map of the Middle East. And what you'll see on this rain map is Israel's right here, and the lines go right across the middle of the country, where north here, it's 20 to 40 inches of rain a year. And below here, it's 10 to 20 and then under 10. Just for comparison, here in Southern California, we average about 15 inches a year. So that would be comparable to what you're going to find in this area right here. If we look at kind of a topographical map of the area, and this is Israel and the occupied territories, you'll see lowlands here. These are foothills going up into low mountains and then high mountains up here. And then right here, there's a steep, steep drop off to the Dead Sea, which is the lowest place on Earth. So here we're looking at Jerusalem is at about, I think, 2,500 feet elevation. And the Dead Sea is about 1,500 feet below sea level.
Wow,
So
that's a
there's
big drop.
Steep drop off right here, and we'll see that in a minute. So if we look at our water map again, and this is now in millimeters per year, so I apologize for the shift, but this map is going to become really important to us when we think about the snails and where they live. From this line, from this isohyet here up, it's Mediterranean climate, like we have here in California. From here down, it's desert.
Oh.
And here we're looking at 1 to 100 millimeters of rainfall a year. That's under 4 inches a year in this southern part of the desert. So we're going to look at the snails from these areas, and we're going to look at what lives where and how they survive. But one of the things that's really important about this map is that the species are actually tied to those rainfall lines. So here are 4 snail species and locations where they are common. And you'll see that they're very connected to, this is the 500 millimeter a year rainfall line. This is 400. And then this desert species is between 200 and 50. So that's very dry. 50 millimeters a year is what? That's
2 inches.
2 inches, thank you. Which is a very small amount. You'll see that they use something else to survive there. So even within a given genus, we find that the species are separated out by rainfall amounts. So this are Sphincterochila species. You'll see Cariosa in the north, where it's relatively moist. Aharoni in the central area here. Fimbriata here, it's a little bit drier. These are steppes, higher area, but still somewhat dry. Zonata, this is under 200, so it's desert. And Prophyterum here in the relatively deep south. One of the things that I'd like you to look at is the shapes of these snails, because they found that the thicker the shell, the more water retention there is. So heavy shells, round shells do better in drier areas. And so you have Zonata and Fimbriata here. When they've done studies of desiccation rates, they found that these species can dry up considerably and still thrive, still do well. This one, not so. And they consider it to be a relic species from when this was all Mediterranean in the past. And you'll see that difference in the lifestyle. These live in sand, and Prophyterum lives under rocks where it's protected more. All right, over the years, I've had a chance to look for snails in a lot of places around Israel and Jordan. The little purple dots are some of the spots. And so I've had a chance to sample these different geographic regions. So what we're going to do quickly now is walk through these regions, what lives where, and what we can learn about them. So the geographic regions are the coastal plain that we're going to look at here, the north, which is Galilee, and there's even a higher mountain here. Mount Hermon is about over 9,000 feet in elevation, which for us is not so high, but for the Middle East, it's a fairly high mountain. This area is called the Shephelah. It's, I guess you would describe it as low foothills. The Judean mountains here, which are relatively low mountains, and then the Judean desert and the Negev. So let's walk through some of these. Let's start in the north. The north of Israel, a lot of moisture, as you saw. It's quite green. There are springs that are really the source of most of the water for both Israel and Jordan, running down the Jordan River. Mount Hermon even gets a fair amount of snow, to the extent that there's actually a little ski resort. This picture was taken a very long time ago, but there you go. These are some of the species that we find in the north, and you'll notice there's one operculate species here that's up on the coast in the north, Pomadius olivieri. I'm going to ask you to pay attention to these because you'll see similar ones change as we move further south. So this Sphincterochila, this is the northern species, Cariosa. They live on the ground and in shrubs. This has been given a new name, so I have to check it. Xeropicta kernicii lives on shrubs. This is Levantina caesariana, which lives in rock, and you'll see how it does that in a moment. Euchondrus, this is Euchondrus solcii, which you'll notice is sinistral. And Bolymulus jordani, which is up on Mount Hermon. Now we see different species in each of these genera as we move south. So even in a tiny space like that, we see speciation as we move from one climate zone to another. The coastal plain. Coastal plains geologically are primarily sand and a lithified sandstone that they call Kirkar, which is found all through the coastal parts of the Eastern Mediterranean. It's wind-blown sand that's glued together by calcium carbonate. So there's calcium carbonate there, but those silica sand granules. This is the home of Tel Aviv, the largest city in Israel. As you can see, it's a fairly large metropolis. It's also the home to these species. You'll notice, again, we have Euchondrus, but we have different species. These are Ovularis here in the middle, and Salcidens. Elia moesta, which is a clausiliid. You'll notice the Sphincterochila is now a little rounder and smooth. This is Sphincterochila aaroni. And this little guy is Xerocrassa davidiana, which is a tiny little snail, beautiful little thing. One of the things I want to point out, if you'll notice, these two euchondrous have dentition in the aperture. They have teeth in the mouth. It's understood that that's a protection against predators. Beetles, there are certain species of beetles that only eat snails. Ants, other predators are kept out. The snail can withdraw back inside the shell and they can't be reached by a predator. The Clausiliid, this one here, also has a protective device. It's like a little calcareous trap door right inside the aperture. It opens, the snail pushes it out when it exits. When it goes back in, it snaps in place and it protects the snail. Now, I want us to look at this guy for a minute, and we're going to move to a different species. This is Xerocrassa picardi. It was listed on the extinct list, the red list, in 1996. A survey was done where these had originally been found in 2003, and they were found alive.
How big is it?
It's about 10 millimeters. It's very small.
Very small, okay.
Very small. Here's a living one. They were found in 3 spots in the middle of a suburb of Tel Aviv, in a suburban area where there were these Kirkar Hill outcrops still extant. Well, I visited those places in 2005. Here's the first one. Whatever was there was no longer there in 2005. This is now just kind of ornamental plants. Who knows what it looks like now, 15 years later. Here was this, here's what it looks like across the street. You can see this is in the middle of a metropolitan area. It's just a suburb of Tel Aviv. It's not exactly out away from people. I was there with an Israeli collector who was showing me these sites. And one of the things that he showed me is that ants, when they build their ant hills, remove objects that are in the way when they're digging their tunnels, and they bring up a lot of snail shells. And so if we look up close, you'll see the Sphincterochila aharoni here. There's a little Xerocrassa right there. So that was site number 1. They're not alive anymore. Again, this was 2005. This is site number 2. And this, again, 15 years ago, it was being built on. What we're looking at in the sand here in the front is now probably parking structures and other apartment buildings. So that site was gone as well.
So like at first I always think like snail, it live in like the forest or like some big garden.
Right.
But
and
you show like even like some dirt, like small area, they can grow from there too.
so this is site number 3. And if you look at the shrubs, soon, Dong, we're going to look at desert that looks like nothing lives there. That's full of snails. Full of snails, you'll see. If you look at these plants, the white that you look at, that you're seeing here in the picture, each of those is a snail on these. So there are a lot of snails living in this environment. The good news, even though many of them were this Sphincterochila aharoni here, each of those circled dead snail shells is one of those supposedly extinct species. A dead shell. But the good news was here was a live one on one of the bushes. Now I want to point out something about this snail. As you can see, he's very small, judging by the size of those leaves. You'll notice that it's glued on with something white here. And it'll sit there for a very long time, glued on with essentially dried up mucus. It's called an Epiphram, until it gets wet, and then it'll come out and feed. Yeah, that'll be important in a minute when we move on here. So what I just want to point out about this particular spot is I found out recently, within the last couple of months, that the city that this is in is working to protect this as an urban nature site. It can't be built on because there are electrical towers there, but people are walking through all the time, and it's very unprotected. So they're now looking to protect it and hopefully protect these snails as well. So that's good news.
Do the snails eat a certain plant?
So yeah, they
Specific?
some of them eat. This one will eat eats leaves, so it'll eat whatever it's on.
Any kind of leaf?
But in a minute, we're going to look at some snails that are much more finicky in their diet.
Okay.
We're going to move to the Shephelah, which is the foothills here. If you look at the rock, you'll notice that it's all limestone. This area is limestone, dolomite, and chalk when you go further south. So another way to say that is calcium carbonate, calcium carbonate, calcium carbonate. Snails love it. Everywhere you look, if I was walking on this hill, I'd see snail shells everywhere. And again, no trees, no forest, a very different kind of environment. So here's another look at that area. There's an old limestone quarry over here. If we take a look at it, we'll see the rock, it's kind of weathered. The snails, again, they live in the ground, they live on the shrubs, and they live in the rocks. And here are some of the snails that are found in that quarry. Again, that Levantina caesariana. This one is, hold on. Euchondrus chondriformis, Paramasta episomis, this little guy, and this one is about 6 millimeters in size. It's a really small snail. That is, whoops, I dropped the name, Rupistrella rhodea, Granopupa granum, a monaca, and another clausiliate here, Christataria. Now, these Levantinas, whoops,
There we go.
you can see a lot of dead shells here at the bottom of the rocks. There's something fascinating about how and where they live. Here again is Uri. He's pointing in, looks like a crevice in the rock. If you look inside there, this is what it looks like. You'll notice
Wow.
there are snails here. That's kind of interesting. They're in there estivating, which is essentially hibernating until it's wet. The piece that's most interesting to me is that they created these holes.
But that is rock, right? It's supposed to be very hard.
It's very hard rock. This is a very hard limestone. And this is a process called Saxicavus activity, where snails burrow in rocks. Now, we're familiar with some marine mollusks that use their radulae to scrape rocks. In this case, it's acid. They secrete an acidic chemical through their foot, and they slowly dissolve the rock. A lot of helicids, even Cornuospersa, the garden snail that people find in their gardens, can do this.
So that like make the hole very fast or like slow, like how is the
It's
speed?
very slow. They've actually measured this. They did experiments by putting highly polished pieces of marble in a controlled kind of a, terrarium with snails and watch them over time. And there was a study done in 1986 where the researcher calculated that it would take approximately 240 years to dig one of these. That
Wow.
means it's many, many generations of snails that have participated in this whole area here. But this is something that we see in many places around the Mediterranean where there are pockmarked limestone rocks. And they used to think it was wind or some other mechanical force like that, but they've now found that actually this work has been done since the 30s even, that snails are able to slowly dissolve the rock away to create these kinds of environments. Okay, we're going to move on. We're going to go up into the mountains here, the Judean Mountains, which is where Jerusalem is. Jerusalem, I believe is the oldest city in the world. The elevation here is about 2,500 feet above sea level. It's supposedly built on 7 hills. So is Rome, so is Moscow, so is Kigali. I don't know, 7 hills, 6 hills, you decide, but it's a lot of hills.
We're gonna put the single seat down and you and I will practice.
What I do again here is when I'm walking around, if there's rocks,
You want me
I
to
look at
drive,
the snail.
honey?
So this is
So you can go sit
the
down.
St. Andrew's Scots Memorial Church. And Roger, if you don't mind, I'm going to mute you. Whoops. Oh, never mind. Okay. But you'll notice next to the church here, limestone rock. And in the cracks in the rock, snails. Again, estivating, you see they're glued on.
How big are those? How big are they?
These are about 30, 40 millimeters. They're pretty big.
So they're pretty big.
They're pretty big, yeah.
And yeah.
And
Oh.
here's another spot. And you'll see, again, they cluster glued to the rock with the Epiphram. There's a different species down here.
We have to we got to put Roger on mute.
Yeah, Roger.
Yeah. Can you hear me?
Let me do that quickly.
We can hear you.
Okay.
1 minute.
Thank you.
Okay. Let's get home.
Right, that didn't work. Well, let's just try to be very quiet and see what happens. I can close my chat window. Hold on.
Oh, please go ahead.
Okay. Okay, we're back.
Okay.
One of the things that I find interesting about this particular snail, this is Levantina Lithophaga, is if you look in the top here, you'll notice this one with a sharp carina on the shoulder, a sharp edge. That's a juvenile. The first 3 whorls, which get big very quickly, as you can see, are sharp edged like that. And then as the snail matures, it gets rounded like the other ones you see here.
Is there any like specific reason they stay together?
Yes, because that's a spot that's protected from sunlight and heat. So they're all looking for the same thing, which is to stay out of
It's
the
like
sun.
optimal home.
Exactly. And so we'll often find them estivating on top of each other, stacked up even, because it's an ideal spot. There's more moisture in the crevices and less sunlight. Another example, this is, I was looking out from my hotel room at another hotel across the way. Behind it, you'll see there's a park, a rockery. snails, the same, glued on. You see, glued on with that Epiphram. And again, I'm asking you to remember that. It'll become important in a minute when we drop into the desert. So these are some of the species that are very, very common all around Jerusalem in every rockery. The Levantina Lithophaga, the Eopolita Portensa, a different Euchondrus. This is Euchondrus septem dentatus, 7 teeth. The same Monaca, Penasidianensis, and this one is very common. And these guys are about, I don't know, 50, 40 millimeters, maybe 40, 50,
Wow.
they're pretty big. And these are just all over the place in the rockeries. Buliminus labrosus. Okay, let's drop down to the desert. So the hills behind Jerusalem look like this. Again, on one side of Jerusalem, it's all trees. It's beautiful forests. On the other side, here's how it looks. And you can see the highway coming down here, dropping down, switching back and forth down to the desert, down to that. So, you know, a distinct climatic difference. This is an example of a rain shadow effect. The winds are coming in from the sea. When they hit the highlands, they drop all the rain. And so it's very dry on the other side of the mountain. So if we go back to that map, you can see that effect here. This area is very wet. Here are the highlands, the Judean Mountains. There's Jerusalem right there where my pointer is. And from that point down, as you drop down to the Dead Sea, very, very dry. Now, the Dead Sea, I don't know if you're familiar with the Dead Sea. As I mentioned, it's actually 1,412 feet below sea level. It is the remnant of an ancient inland sea. It's extremely rich in minerals. It's 10 times more mineral rich than seawater. It has the consistency of dishwashing liquid. It is so dense and so heavy, you can't sink in it. So one of the popular things to do is just to float. You can't swim. You don't want to swim because if you get this in your eyes, it's rather unpleasant, as you would imagine. Imagine taking rock salt and putting it in your eyes. It's no fun. I also tell people who've never gone before to not shave before they go to the Dead Sea because you have any cuts, you know it. This is a very popular place for European tourists to go to the spa, to bathe in these waters in a controlled spa. They sell mud from here. There are places where you can put mud on yourself. This sea is shrinking now because the water coming down from the north has been taken on both the Jordanian and the Israeli side for agriculture. And so now what we're seeing is the resorts that used to be on the edge of the sea, you now have to take a tram to get to the beach.
That's a lot.
So how is the smell? Because when I go to Salt Lake City, the smell not so pleasant.
It's very sulfurous. It has kind of a sulfury smell to it, particularly the mud. The other problem that we've had with the sea shrinking is large sinkholes are opening up. The road, the last time I was there, the road, instead of going straight, had to go around a sinkhole. There were date orchards that had fallen in sinkholes. So there's a lot of work being done jointly between Israel and Jordan to figure out how to replenish the water in the Dead Sea. So that's not snails, so we're going to move on, but I find it an interesting place. Another place down in the Judean desert is a fortress from about 2,000 years ago called Masada. This was built by King Herod, and this was one of his palaces here. It was eventually destroyed by the Romans in 70 AD, or in the 70s, I think 77. But this is a very steep-sided, I guess it's a mesa technically. There's this path that goes up to the ruins at the top and goes down. Now, of course, most people are there to look at the ruins, but and to hear the story of what happened there. I'm always looking for snails. Now, again, look around, look at this environment. This is anything but forest, right?
Yes.
Here's what I see. These are snail shells that were washed down by winter rains and are just in the rocks along the path. These are the species. And this is the point where I start asking the question, how do they survive in the desert? How in the world do they manage? If you look here, is there something that all of them have in common that might be helpful in extremely hot environments?
The shell is very thick.
The shells are thick. That helps them retain moisture. Also, look
The
at
mouth
the
is
color.
big.
Look at the color. White shells reflect more light than shells with color on them. And so you'll find in desert environments that the shells tend to be very light in color. This one here, the Sphincterochila zonata, is able to survive not only for months without water and food, but they've actually recorded them for years. What they do is by estivating, they shut down their bodily functions to barely functioning at all. They take in very little water, and they survive until the next rain. Now, I mean, look at this terrain. There are some plants you can see here, you can see here. The plants are following wadis, what we here in Southern California call arroyos, dry riverbeds, because that's where the moisture is. But snails are all over. I mentioned the Epiphram before. One of the ways that they survive is by creating this Epiphram out of mucus and calcium. And in this case, this one has 1, 2, 3, 4, 5, 6 epiphrams. As the snail withdraws into the shell as it loses moisture, it creates another one. That creates an air buffer. Well, here, let me show it to you this way. There is an air buffer here to keep it cool. This white spot has more calcium in it, so more air can get through between the grains of chalk. And this little thread called an arista is basically chalk that keeps the snail animal here in contact with the outside. Why is that important? When it's really wet outside, the animal comes out, reproduces, eats, does all of its business, and then goes back in the shell. That could happen a handful of days during the year.
So when they send there's the water, so they will break this wall to get out.
Right, right. When an epiphram becomes moist, it becomes flexible.
Oh, I see.
But there's also a chemical that the snail produces that starts dissolving it. And then they just break out, and you'll find epiphrams lying around where there are a lot of snails. It's like
because this structure is similar to the structure of the nautilus. But for nautilus, they use like a valve.
Yes, but this
one
is
they use
not,
for protection.
This is not hard. This is, think of it more like rice paper in texture.
Okay.
It's very soft and thin, but it lets through air, not so much moisture. And then the other thing that helps in their ability to live in the desert is their diet. Most of the snails that live in the deep desert don't rely on green plants for food. They eat lichen. So there are two types of lichen. I'm just learning this stuff myself. I'm no expert. There are endolithic lichens that live on top of rocks. And, I'm sorry, epilithic lichens that live on top of rocks, and endolithic lichens that live buried in rocks, up to a couple millimeters in the rock. Some of the snails graze
Can you hear me?
epilithic lichens
Yeah, I think
around the edge of the colony here, and some of them graze the endolithic. Okay. What we see in this picture here, the lighter colored spots are areas where snails have grazed. Now, what's interesting is that they don't just eat the lichen, but they also eat the rocks. And as a result of this, they found that these snails are a critical part of the ecology of this part of the desert. And I'm going to give you some facts and figures as soon as I get my notes up. If these three species, these are three Euchondra species, again, with the dentition that we've seen in the others. These live in the deep desert, and these eat the endolithic lichens that live.
I think Roger just say that his phone battery is just 2% now.
Oh, that's okay. So we may be saying goodbye to Roger.
I'm gonna lose you, Phil.
Yeah. Okay.
Goodbye.
Bye.
I'll talk to you later. Bye bye, Roger.
We're almost done anyway. If these three live under rocks in areas where there's maybe 3 inches of rain a year, maybe 2 inches of rain a year. But they come out during the 200 or so days a year during the winter and spring where there's a lot of dew, because the temperature drop during that time of year is significant enough where you have a lot of dew. So they come out at night and they graze on the lichen. Here's a picture of what those rocks look like. They're grazing between the colonies. And as a result, many of the rocks in this part of the desert look like this. Now, for the longest time, they thought that these channels that you see in the rocks were made by lichen. But in reality, it's these snails. And these snails are pretty dense. When they surveyed them in one area, they found about 20 snails per square meter. And they come out at night and they eat about 4 to 7% of the rock face in the area that they're in, to a depth of almost 2 millimeters. And they've calculated that over a year in an acre, that 800 pounds of the sand in a given acre is produced by snails. So in reality, much of the sand in this part of the desert is created by these snails who live under these rocks, come out and eat the lichen at night, and then go back under during the daytime. Just as an example, wind-blown sand in the same area, they calculate as bringing in between 200 and 400 pounds of sand per acre. So that means anywhere from 2 to 4 times the amount of sand in that landscape that I showed you is made by snails. Now, the other thing that's interesting is they don't digest all of the lichen. 5% of it is being discharged in their feces. And so they actually produce a lot of the nitrogen in the desert. So in reality, these snails not only live there and survive there, but they're a critical part of that desert environment. So, you know, if we look at this kind of landscape and think about it as a place where nothing lives, and, you know, certainly mollusks can't live here, the reality of much of this landscape was actually created by snails. So with that, are there any questions?
So is there any shell that's very unique and it just live in Israel? Because
Yes, so there are many of these species are endemic, but endemic to a larger area. In other words, sometimes their range goes up through Lebanon. I mean, I can go back and look at some of them have very limited range. These three, for example, have a very limited range, and they're only found in certain parts of that desert and no place else. But again, that's on the species level. This genus, Euchondrus, is found throughout the Eastern Mediterranean and in Cyprus.
okay.
So, any other questions?
No, very interesting.
Okay.
Thank you.
Yes, very nice
I
talk.
appreciate your attention.
Thank you.
I'm going to turn off the recording.